Please, question one.
我觉得中国男生，我觉得中国男生撑起一片天了。
I think we need to what you wanted about the mathematical finance. Okay. Alright, if you need anything more, just let me know. And you do question one, guys. Question one. You already done it. Oh, that's very good. That's very good. Can you guys do question one, please? You need the lecture notes to do this question. If you need a spare one, I've got one. I can give it to you for £10. If you need a spare one, here it is. Anybody who hasn't got that, do you have one? You can use this. You can use it. You need the lecture notes for this section. that's okay. Everything okay? How are you, sir? You alright? How is it you follow that? What you sick over? Hi. You're okay? You've got the lecture on it, right? You need to know any of you guys, you have to rehearse it. You have started. They don't have it. You have it. You haven't started. Most probably you can derive this using the Neiman Freud. You can derive this using I'll do some examples of this. When you say most probably, it means that these just was derived addition here. Yes, that's why it's there. You're right, sir. Yeah. You're doing question one? Yeah. All right, guys. Could you listen, please? Guys. Guys, are you listening to me or what? Question one is not really difficult, right? Because you're testing for what? Theta equal to theta 0 versus theta less than. So the power function, by definition, is the probability of rejecting H0 given theta. Now, if you look at the lecture notes, you will see the rule for rejecting is root of n divided by sigma then what? Less than minus. All right. Now, to simplify this, guys, you must realize that the true population mean is theta, not theta 0. So what should you do? You should replace theta 0 by theta. You see what I've done? I have replaced theta 0 by theta, so I need to do this, guys. Alright? Now, what I'm going to do next is I'm going to take these two guys to the right hand side. So this becomes the probability that root of n by sigma yeah. Now, what can you say about this, guys? Remember from if you were here like in week 1 or week 2, you probably remember that x bar has a normal distribution with these parameters. Right? This is a result that we proved, or that I proved in week 1 or week 2. Week 1 or 2, right? I proved this result. Now, using this result, this will have what distribution? The standard normal distribution, alright? So using this result, it will be n01 less than minus z alpha root n by sigma theta minus theta 0. Now the conditioning disappears because we have used the conditioning to argue that this has a standard normal, and therefore we don't need the conditioning anymore, right? So this is equal to phi or phi yes, it's really easy, right? Or is it not, guys? Any questions, guys? Your answer? You okay? Any questions, any of you guys? Now, let me also do question 2 because it's very similar. Question 2, sheet 9, because they are all the same kind of same bunch of questions. So to do this, the only difference, guys, to do question 2, it's just the rejection rule is different. Everything else is the same, right? So you have root of n by sigma x bar yeah, this is the only difference, guys. Instead of less than, you have greater than. Yeah, that's the only difference, right? Oh. Yeah, so this becomes, now applying the same trick as before, yeah, you do this. Now then you take these two guys here, you take them to the right hand side, so it becomes yeah, yes. Now this, as I said before, this has a standard normal distribution, so this is the probability that n01 is greater than z alpha minus root of okay, and this are you with me or what? This you can write it as 1 minus phi or phi Alright, so that completes question 2 too. Now can you guys do question 3? Unless you didn't follow this. If you didn't follow this, ask me now. Tell me where you Are you guys okay with this or not? You're okay? Okay. Yeah. Can you guys do 3, please, if this is okay? It can be anywhere, any positive. Yeah, you need to like do calculation. You need to do some kind of approximation. Yeah. Question exactly. But if you have a computer software like R, there's a software called R. You can R can give you any value. Like even if it's not an integer, you can still get it doesn't need to be integer, no. It can be any positive value. Are you guys okay for watching? You get the formula sheet. You should look at the cost vector. If you know the cost page, yeah, it gives you the list of formulas. Yeah, this is what I gave you in my notes. But I mean, today I told you like some people they said that they will talk differently. So that's why I said instead of X bar, you can also use P0 in place of X bar here and X bar here. So you can use P0. Yeah, that's right. But this you can't assume so because you're assuming the true value is P, not P0. They test it with P. You have to say this is not right. It has to be P. Not P0 times or minus P0. You know what I mean? Because when you try to find the proper function, you're conditioning on P. The true function is P. So you assume that X bar has normal distribution, mean P, and variance is ideal. One P0. P0 is only the null. Yeah, I use this one for my solution.
其实我觉得确实就是大部分团队来讲，中国技术个人学习的话，真的每条可以有一个长度。技术那甚至相比来说，比起来差不多
Yeah, that's okay too. That's okay because it's okay to achieve expansion, right? Even for this. Yeah.
C 罗算是这都是中色的，C 罗
You guys done question 3, guys? Yeah, that's not example. Yeah, it's not I want to do 8 and 9. This week we are doing 9. Next week, the week after. Yeah, I will skip pairing also. I will not do
这些智商不是特别大，不可能，他就是这样这样学的。分别还是靠在图上去，他们的权利研究权。我但是他想不出来，就是说，其实并不一定会像他们这个高中的水平跟我们都是一样，我觉得这个还是完全不完全是他总体的存在，就打这个就系统中国是中文学的。
All right, question 3. All right, guys. Now, let's deal with this. Now, if you follow the formula, there are, as I said in the lectures today, you can there are two different types of rules for proportions. You can either use the x bar in the denominator or the p0 in the denominator. Yeah, I will stick to the x bar definition. Okay. So you should stick to that definition, guys. The rejection rule is this is the rejection rule, right? I mean, you should follow the rejection rule in the notes, not the one I gave you this afternoon. The one I gave you this afternoon has P0 in place of X bar, right? Yeah? You guys follow me or what? Yeah? So this is the rule for rejecting the null hypothesis, okay? Now the next thing you need to do, guys, is to, because the true proportion is P, the true proportion is P, you have to replace P0 by P. So you need to add a P and keep the P0 here, guys. Alright, the next thing to do is to combine these two and take them to the right hand side. Right? Are you following me or what? Now I'm gonna assume, guys, that X bar has this normal distribution. This is only an approximation, right? This is what, remember this notation here. It means approximately distributed as. I think I told you this before, right? This means approximately distributed as. That's what this notation here it means this, right? Okay, now you should make this assumption, right? You should make this assumption. Then this guy here will have the standard normal distribution, right? So this will become n over 1 less than, oh, I left out oh man, there should be a square root sign here. I left. Okay, you guys following me or what? Yeah, the condition is no longer needed because I used the conditioning to argue that this has an approximate standard normal, and this is phi Alright, so this is the answer, guys. So this should be an approximation, not exact. This should be like a simple like this, meaning approximation. Okay, so this is the expression for the power function. Now question 4 is very similar, so you know what to do. Did you guys follow this or no? Huh? Yeah, too simple for you, right? No? Yes. It says in the note. That's the rule for the note. You can't find it? I think there's a page missing, man. What is this page now? 20? I didn't look it up. You can check. Yours is also missing. Check this for me. Susan. So I said, yeah. Did you follow this? Sir? Yeah. You already done. That's good. Well, I'm gonna do some extra problems today. After you're done with this. After I'm done with this, I'm gonna do some more problems. Which one wait? You don't mind waiting? Anyone who hasn't signed, anyone who hasn't signed the definition. Oh yes, you guys okay? Yes. Random variable is like function for data. It's a function. And it is a random variable, but this is like the data. It's not like have a data set. You should have a data set. You should have a real data set. Yeah? And X bar will be a number. It will have a numerical value. It will have a numerical value, not a random variable. I mean, it is a random variable, but it will have a numerical value. So, but you should treat this. Not as a whole. Is the object. It's going to have a function of X bar is just a quick yeah, same thing. Yeah, same thing. You can use all the same doesn't matter I'll give you a printout if you come to my office. The missing page. So I think it must be my fault because maybe when I printed it out. All right, guys. So this is question 3, right? Question 4 is similar. Guys, I know many of you have already done question 4. Yeah? Yeah. Now we know that this guy here, because of the approximation that we are assuming, we can say that this is approximately standard normal, right? So we will say this is approximately all right, because you know what I'm saying by this approximation. I talked to you about this earlier, right? So now this one you can write it as 1 minus phi okay. So that's the answer, guys, for question 4. Now in the remaining time, I was going to do another question, a couple of questions actually. Let me see if I can find it. Yeah. Is this clear to all of you guys, by the way? Yeah. Now, in the remaining time, you may remember from last week. Do you guys remember this? This is sheet 5. This is the sheet that we did last week, guys. This is sheet number 5 from, and if I remember correctly, I did not do question 5 and question 6 last week. Yeah, we managed to do only the first 4 questions. So what I'm going to do in the remaining time is to do question 5, depending on how much time I have. I may also do question 6. All right. So let me take this away. Put this here. I'm going to start by doing, so the first thing I'm going to do, guys, the first thing I'm going to do is question 5. So you have x1 Alright guys, are you listening to me or what? Shh. The question was to find the value for n. N is a sample size such that the probability that you reject the null hypothesis when the true value of mu is 95 is at least 0.9. So the question is, what is the value for n if this must be greater than 0.9? Yeah, this was the. Do you remember the question, guys? It's here. This is the question, guys. Right. So the question is to find n sample size. Right. Now this is the same as the probability that we reject the null hypothesis if root of n by root of 20 times x bar minus 100 is less than minus z.05 given this. Do you know where, I'm sure you know where this comes from, guys, right? This is the rule for rejecting the null hypothesis that comes from the lecture notes, right? Yeah. Now the true value for mu is 95. So what the next step must be to change the 100 here to 95. Okay. So the next step, I'm going to change the 100 to 95 because the true population mean is 95. Okay. Not. Okay. Now I'm going to combine these two guys and take them to the right hand side. 95 minus 100 is minus 5. You should take it to the right hand side. It becomes plus 5 root n divided by root 20. Do you guys see what I've done, guys? Yeah. Now what can you say about this? This will have the standard normal distribution because we are conditioning on the true mean being equal to 95. So this must have the standard normal. Alright, so what you have is the probability that n01 is less than we don't need the conditioning anymore because we've used the conditioning to argue that this has a standard normal. So the conditioning is no longer needed. So this is the same as phi or phi okay. Now the next step I'm going to do, I'm going to take the inverse function on both sides. Now if you take the inverse of this, multiply by the inverse of this on the left and the right, you will get the following. Do you see how I got this, guys? I multiplied by the inverse both sides, left and right. Yeah. And then you get this. Then you get this. And finally, if you take the square both sides, root of n becomes n. This will become 20 divided by 25. All right. So that's the answer, guys. So this is the answer to the question. The sample size n must be greater than this number, right? Now, of course, if you have a calculator, you can work this out what the number should be. Yeah. Yeah. All right, guys. Can you do question 6? Question 6 is not difficult. So question 6. So is, I guess okay with this or not? Yes. Anyone who's not clear about this? Oh. How is the guy at the end? Are you okay with this, sir?
Yes.
Yes. Oh, you're always okay. Good. Okay. All right. Now, question 6. Question 6, which is this one here. This is question 6, guys. This is question 6, sheet 5. I think you are given you're told alpha is 0.05, and you're asked to find the probability of type. Yeah, you also given n is 35. N is the sample size. All right, this is all the thing that you're given, and you're asked to find the probability of type 2 error, right? Remember, the type 2 error is what? Is the probability of accepting the null hypothesis when h1 is true. In this case, h1 is true if 2 sigma is 2 times 10 to the power minus 2, right? Now, if you guys look at the lecture notes, one more time, guys, if you look at the lecture notes, you will know the rejection rule, because we did this in the class. You will know the rejection rule for this versus this. And you guys look at the notes, please. It says what? It says n minus 1, 35 minus 1 times s squared divided by sigma 0 squared, which is 10 to the power minus 2 squared, is greater than chi squared 34.05, given sigma is 2 times 10 to the power minus 2. Do you see where I got this from? Do you know where this comes from, guys? It's not magic, guys. It comes from the lecture notes, guys. Yeah? Yeah? Now, the true sigma is equal to 2 times 10 to the power minus 2, which is not the same as this. So the next step you must do, guys, is can you explain to me why I have done this, guys? Why have I multiplied by 4 here and multiplied by 4 here? Multiplied by 4 and divided by 4. The reason I have done this is because we are conditioning on the true sigma being equal to this. Yeah? So therefore the true variance must be 4 times 10 to the power minus 4. If this is a true sigma, the sigma squared must be 4 times this. Okay? Now, let me ask you guys. I just mentioned this in the lecture today. I'm sure what can you say about the distribution of this? Because I just mentioned this in the class, in the lecture today. What distribution will this have and why? It will have, if you look at equation 72 in the lecture notes, you will see that this guy has the chi-square distribution with 34 degree of freedom. Is n minus 1, okay? So that completes question 6. Is that clear, guys, or no? Yeah. Some of you look. Is it? I mean, this is pretty standard. I mean, stuff we have been doing. Anybody not clear? Come on, guys. You should. All right. So see you guys tomorrow in the lecture. Please come. Right. Tomorrow we will do some. Had you all signed the attendance sheet, guys? Anybody who hasn't signed the attendance sheet? Yes. Yes. And that one is true. Yeah, because you're given the value for sigma, so you have to use it. You know, you should read the question, madam. Where's the question? You have a question. Where is it? It's here. It's here. I have it, sir. It's here. I have it. It says the true value for sigma is 2 times 10 to the minus 2. Yeah, so you need to use this. So when you compute the type 2 error, you need to use the true value for sigma. Satisfies h1 because h1 is sigma greater than 10 to the minus 2. And this satisfies this. So 2 times 10 to the minus 2 is greater than this. So you have to function this. Yeah. You guys have a question or what? No?
Just a simple question. Just changing to the number, so
Yeah.
just a bit.
So, you want to see me in my office? I'll print out the page one. The missing page. Huh? You can come to my office.